continuous distributions now, so we're looking at measurement. And the first one is the uniform. The uniform one doesn't come up very much, but if it does, it's a good simple one. The key here, and it becomes the key for picking the questions in the exam and deciding which distribution to use, is we'll be dealing with a measurement. In this case, it's time, length of weight, and will only be supplied with the range. So this is the thing that identifies it as a uniform distribution. So we're only given the range, we're not given an average or a middle point or a mean point or anything. And so we assume, therefore, that anywhere on the range is equally likely to occur, and that gives you this uniform distribution, which is often called the rectangular. That's another term for it. So the situation would be reasonably simple, something like this. A wait at a taxi stand could be any time from 1 to 15 minutes. Find the probability that the wait is over 12 minutes. So we have a simple sketch of it here on an axis. Imagine a time scale down the bottom from 1 to 15. This isn't a scale. The area of the total rectangle, because it represents all probabilities, the area is 1. And so, as I stated down here, that's probably the key thing, just like we used to with the normal distribution, and we'll see again shortly. Then the height will be 1 divided by the total range. So if it's a really long range, it'll be a low, skinny triangle. So X stands for the length of weight and measured in minutes. And the question is asking us, what is the probability that X, the weight, is greater than or equal to 12? Now, the total range always goes on the bottom. So there's a range from 1 minute through to 15 minutes. Okay. The weight's going to be somewhere on that boundary, so we put a 14 on the bottom line, that's the difference. And out of that range, how much of it fits what we've been asked for? And in this case, only from 12 to 15, so 3 out of a total of 14. It's a good entry-level distribution, and it's come up a couple of times, and it's just about due to come up again in 2020.